notice, and this is a typical copyright 2018-2027 mathematics syllabus for CSEC. Schedule of videos by September 2024, which is this month. I'm hoping to have all 32 videos from section 1, and then October, those November, December, January, February, March, April, and May, early May 2025 or late April 2025 to have all the videos completed. As pointed out, this section 1 has 32 videos, all of which will be made available on YouTube in their entirety. Please make sure you know section 1 very well before you go on. Right now, we are here. Objective 3, section 1. And notice this objective 7, where we will be talking about base system. So this objective in section 1 says evaluate numerical expressions using any of the 4 basic operations on real numbers. And it further explains that we have to deal with addition and multiplication, subtraction, and division of whole numbers, which we will look at first, then fractions, then decimals, and then we also need to look at order of operations. By the way, this that you see here is a print screen from the syllabus. Just a reminder from previous class video, what we mean by real numbers. That would be everything included in this box that you see here. You have the irrational numbers, and then you have the rational numbers, which are made up of fractions, terminating and recurring decimals, made up of integers, which include whole numbers, which include the natural counting numbers. So those are the numbers we will be adding, subtracting, multiplying, and dividing. The whole numbers. Whole numbers, for this objective, we have to do that with whole numbers, with fractions and decimals. So that is too much for one video. So I have divided it into 4. Now, before we go any further, I am again emphasizing that you need to know the times table, the multiplication table. Remember that in paper 1, a calculator is not allowed. So we will be looking at this part of the objective. Here again is one format of that multiplication table that you must know. For example, 4 multiplied by 6 is equal to what? 24. And then 7 multiplied by 8 is equal to what you come across under the 7, and you get 56. And so on. 9 times 8 is equal to what? 72. Or 9 into 36. And we come across here and we get 4. Or 7 into 84. We go up here and we get 12. Or 3 times 9. We come across here and we get 27. And 9 into 63, you go across here and you get 7. So you must know this table very well. So, okay, so now let's get down to business, so to speak. Most people, when they hear about mathematics, they think about addition, multiplication, subtraction, and division of mainly whole numbers, but also fractions and decimals. Now, in this video, we are looking at part 1 of Objective 3, Section 1, we will be talking about addition, multiplication, subtraction, and division of whole numbers only. And in subsequent videos, we will deal with decimals and fractions. But we need to understand the concept of base 10 first. So we will spend some time on this. Now, this is a base that we normally use for doing things with numbers, everyday things. We need to understand base 10 for two reasons. One, we can be aware of what we are actually doing with these numbers and why. And two, the same principles that are applicable to base 10 are also applicable to other bases, for example, base 5, base 8, and so on. And in Objective 7 of this same section, we will be dealing with more bases. So, base 10. If I were to ask you to write the number 456, or you may say 456, you will not do this. You will not write a 400 followed by a 50 followed by a 6. That is what you will not do. Rather, you will write it like this: 4, 5, 6. Now, this does not look like the one we have over here, where you could actually see a 400, a 50, and a 6. But this is the way you write 456. So first of all, you write 4 in that 100 space, and then you write 5, which is the 50, in that tens position, and then you write 6 in the ones position. And so this is how you write 456. If I were to ask you to add these numbers without a calculator, you will write 475 like that first, and then you will write 89 like this, with the 8 on the 7 and the 9 on the 5, and then that 7 you would write to this far column on the right. You set it down like this for a reason. And then, of course, you add it. We will come to that in a little while. You will not do this. And that is because these numbers are in the wrong column. So you will not do this. This here does not make sense. Now, let us go back to like grade 2 and learn to count P's or stars. So if you drop a grid, over here, we are going to put in this column, we are going to put ones, and on the left-hand side, we are going to put groups of 10 ones. So if we count stars, we count 1, 2, 3, 4, 5, 6, 7, 8, 9. At this point, we have 9 stars here. Now, keep in mind that in base 10, we have 10 digits, 0 to 9. So 9 is the highest digit we can write in one of these columns. Now, if we add one more star, we now have 10. That creates a problem because you cannot write 10. 10 is not a single digit. You cannot write 10 in this column. So what you would have to do is group those 10 stars into one group and then move them over on this side. So at this point, you now have 0 star in this column and one group of 10. If you add some more stars, that would be 1, 2, 3, 4, 5, 6, 7, 8 more. So at this point, we have that one group of 10 and we have 8 single stars, units. And so we say we have 18 stars. But in saying we have 18 stars, we do not think normally that it is really one group of 10 and 8 individual stars. We don't think of it that way. Let's add some more stars. So that's 18, 19. At this point, we now have 9 stars here. If we add one more, we create a similar problem that we had just now. We cannot write 10 here. So we have to get rid of that 10, put all those 10 stars in another group here, and move them over to this side. So what we now have is two groups of 10 and no star on this side, no star here. So when we write 20, we normally don't think that we have two groups of 10 and zero single stars. So if we add some more, at this point, we now have, instead of 0 here, we have 4 here. So we have 24 stars. That means we have two groups of 10 and 4 individual stars. So any two-digit whole number means two columns are in use. The left column is group of tens, and the right one would be single stars. So let us say we have been counting stars for a little while. We now have 9 groups of 10 here, and we have 2, 4, 6, 8 over here. So that would be 98 stars. 9 groups of 10 and 8 ones. Now if we add another one here, we now have 99. If we add another one here, we have a problem because we cannot write 10 in this column. So as we did previously, we will take all of those 10 stars, put them in an individual group, and move them over on this side. But that creates a problem for us because while we now have no single star here, we now have 10. And we cannot write 10 in any one of these columns because this column could take up to 9 groups of 10. So what we will need to do is group those into one large group of 10 of 10s and put it over here. Now, 10 of 10s would really be 100. So we now have one group of 10 of 10s, which is 100. We have no group of 10, and we have no ones. So this is what 100 means. One group of 10 of 10s, no 10s and no ones. Now, if we were to add some more stars like that, we now have 105 stars. So we write 105. Assuming that we were counting stars, we now have two groups of 10 of 10s. We have 2, 4, 5 groups of 10, and we have 7 single stars. So if you write 257, this is what you mean. 257, that is two groups of hundreds, which is 10 of 10s, 5 groups of 10, that is the 50, and 7 single stars. So if we keep counting stars, we now have 9 groups of 10 here. We have 2, 4, 6, 8, 9 groups of 10, and we have 2, 4, 6, and we have 7 single stars. So at this point, we are writing 997, meaning 9 groups of 10 of 10s, 9 groups of 10, and 7 ones. If we keep adding another star there, we now have 8 here, and another one will give us 9. At this point, we have 999. If we add one more, we now have 10 here, but you know we can't write 10 here because that column could only take a single digit from 0 to 9. So we create a group of 10 and bring that over here. That creates a new problem here because now we have 10 of this group. And by the same token, we can't have 10 in a single column. So we take all of those from there, create a new group like that, and bring it over here. But that creates a new problem for us in this 10 of 10 group because we now have 10 here. We cannot write 10 in a column. So we will collect all of those 10 into one big group and put them over here. So now we have 10 of 10 of 10s. We know that better as 1,000. So we have one group of 1,000. We have no group of 100, we have no group of 10, and we have no ones. So 1,000 means one group of 10 of 10 of 10. No group of 100, no group of 10, and no ones. Let us say we kept counting stars and we now have three groups of 1,000, 10 of 10 of 10s. We have five groups of 10 of 10s, that's 500. We have seven groups of 10, and we have two here. So the number of stars we really have here would be 3,500, 70, and 2. So we say 3,572. That is three groups of 1,000 each, five groups of 100 each, seven groups of 10 each, and two stars. So notice that once this column reaches 10, we have to take those 10 and put it in a column on the left. And once this column reaches 10, we have to take those 10 and put it in one group over here, and so on. Remember, we are talking about base 10. Another way of looking at it is this way. If we drop a grid and we put ones here, and then we put tens here, which would be 10, and then we put 10 of 10s written like this, 10 of 10s, and in this column we put 10 of 10 of 10s, which would be that. Next column, group of 10 of 10 of 10s, 10s, written like this, and the next column we write 10 of 10 of 10 of 10 of 10. Now, another way of writing those numbers that you are more familiar with would be 1, 10, 100, that's 10 of 10 is 100, 1,000, that's 10 by itself 3 times, 10,000, and 100,000. There is a different way we learned in the last video that we can write these numbers. For example, 10 by 10 can be written as 10 to the second power, and 10 by 10 by 10 as 10 to the third power, and so on, 10 to the fourth power, 10 to the fifth power. Notice this is why it is called base 10, because recall we said that that is the base and this 2 up here is the index. So we're counting in groups of 10. And if you write it out in this index notation, you can see clearly a base 10, because this is 10 to the first power, and this is 10 to the 0 power, so that 10 to the 0 is 1, 16 to the 0 is 1, q to the 0 is 1. Only thing to the 0 that is not 1 is 0 to the 0, and we don't know what that is. So that's base 10. We know now why this is called base 10. But there are other bases too. There are base 7 that has 7 digits, 0 to 6, so that this first column here would have ones, just like in the base 10, would have ones. But this second column here would have 7 to the first power. So this second column, unlike up here that has 10, will have 7. And this column here, this third column here, will have 49. So up here, if you write 2, 6, 3, that means 2 groups of 100, 6 groups of 10, and 3 ones. But down here, if you write 2, 6, 3, it doesn't mean the same thing as up here. This means 2 groups of 49, 6 groups of 7, and 3 ones, and so on. If we take base 3 has only 3 digits, 0, 1, and 2. This right column here is 1. This next column here is 3. Now remember, in base 10, that column there is 10. In base 7, this column is 7. Now in base 3, this column is 3. And of course, if we take this third column, we have 9. So let us say you have 2 here, 1 there, and 1 there. On base 10, that would be 2 groups of 100, 1 group of 10, and 1 single one. But because this is base 3, that will be 2 groups of 9. This will be 1 group of 3 and 1 single star over here. So this is just an introduction to base 10 and other bases. We will come back to this in detail later on. Now we come back to what we started doing. Base 10. Remember we said if you were to write 450 and 6, you will not write that. You will write it like this. It's like you are writing on 400 and then 50 in that position there, 5 in the tens position, and then 6 in the ones position, and then you add them all and you get 456. Now, if you don't see a decimal point in a number, it's on the right of the digit on the far right. So actually what we do, we line up all the points. So let's go back to this. If you have to add this, now you would have been doing this in maybe grade 1 or grade 2, where you draw columns and you say in this column here, you put the ones, the next column there, the tens, the next column there, the hundreds. So that 475 would be written like this: 475. The 89, that's 8 tens. You write the 8 in the tens column and the 9 in the ones column. And then this 7, the 7 ones, you draw a line like that and you add. Now, when you add the ones column, you get 21. Normally, you are told to cross out that 1 and put it here under that 7. And to take the 2 and carry it above there over this 7. But do you know why you do that? Now, remember we said this is base 10, so we're working in groups of 10. Actually, because this 21 is more than 10, you divide it by 10, and so 10 into 21, you get 2, and you get a remainder of 1. It is this 1 that goes down here that you would have crossed out from the 21 without knowing why you are doing it. But you see you have 2 groups of 10 now, so that 2 goes over on the 7. So now you add, we are dealing with groups of 10, 8 and 7 and 2, and you get 17. You are told to cross out the 7 and put it in this column here. But the reason you do that is that this 17 is more than 10 groups of 10. So you divide that by 10 and you get 10 into 17, 1, and you have a remainder of 7. Now that is 7 groups of 10. That 7 goes there. Of course, you have 1 here. That 1 is 1 group of 10 of tens, which is in the hundreds. So that 1 goes above this 4, and you add that 4 and that 1, and you get 5. Okay, now what you are accustomed to doing here, please keep doing it. But now you know why you cross out that 1 to begin with first, and that 7 to begin with first, and why you take that 2 and put it there. You will not write this because you cannot add these numbers. They belong to different columns. Cannot do that. So if you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel. Now, so we dealt with addition. Now let's deal with subtraction. Subtraction of whole numbers. From 378, you need to subtract 65. So you set it down like this. Remember to set down the hundreds in a separate column, the tens in a separate column, and the ones in a separate column. So now you start subtracting. 5 from 8, and you get 3. 6 from 7, you get 1. And 0 here from 3, you get 3. So that's 313, and that was pretty easy. Now let's look at one that is a little more difficult. From 357, subtract 179. Now think of it this way. You have three $100 bills, you have five $10 bills, and you have seven $1 coins. From that, you want to pay out one $100 bill, seven $10 bill, and nine $1. So you set it up like this. And you begin by saying, I have seven $1 coins, and I want to pay out nine from that. I can't do that. So what I can do, remember this column here has 10 of whatever is on the right. So I'm going to take one from this five, leaving four, and that one would give me 10 on this right column here. 10 plus that seven would give me 17. Now I have 17 $1 coin. I can take out nine from that, and I have eight. Now I need to subtract seven from four. Well, we can't do that. So remember, this column here is hundreds, this one here is tens, so that if I take one from that three, I am going to get 10 of the tens, add that 10 to this four, and I now have 14. So 7 from 14, I get 7. 1 from 2 gives me 1. So you are still left with one $100 bill, that's 100. Seven $10 bill, that would be the 70, and eight $1 coins. Now suppose you have two $100 bills, five $10 bills, seven $1 coins, and you want to pay back your friend some money that you owed her. Specifically, you want to pay back three $100 bills, seven $10 bills, and nine $1 coin. Now, obviously, you have a problem. The problem is you want to pay back more money than you have. So this is the amount of money you have. This is what you want to pay back. We have a problem here. So what we will do, we will put the larger number at the top and place the minus sign directly in front of it. Then we will put the other number below it and subtract as usual and keep the minus sign in the answer. So this is the larger number that we owe. Put a minus sign there. This is the one that we have. We subtract like this normally. So we subtract that. We keep the minus sign in front of the answer. So 7 from 9, 2, 5 from 7, 2, and 2 from 3, 1. Now this minus sign here means that you still owe your friend $122. If you are asked to add negative numbers to a positive number, like 456, remember this 4 has a positive in front of it, plus negative 45, you simply subtract the one that has the minus sign in front of it, just like we did up here. Now, one more thing before we leave this topic of addition and subtraction of whole numbers. If you have to subtract a negative number from another negative number. So let us say from 257, you need to subtract 79. Let us say that you have a credit card for $500 and you spent $257 from it. It means that right now you owe the credit card company $257. But then you went and you buy something for $79. Now, how much money do you owe the credit card in total? So you simply add the two numbers and you retain the negative sign. So this was what you owed to begin with. This is how much more you spent. You add those two. You retain this sign, which means that you now owe the credit card $336. Now, the general rule for addition and subtraction of whole numbers, recall that if you don't see a sign in front of a number, assume that there is a positive sign there. Also, you would not normally write a positive sign in front of a number by itself if it should have a positive sign. So if the numbers have the same sign, two positive or two negative, what do? You add them, as we will see just now, and retain the sign. And if the number have different signs, what do? You subtract the smaller number, smaller there in quotation mark, from the larger number, and you retain the sign in front of the larger number for the answer. For example, 25 plus 32, that's two plus sign, you just add them and keep the plus sign. You don't write it. 32 minus 25, there is a plus sign here. Two different signs, you subtract and you keep the sign that is in front of the larger number. So that's 7. 25 minus 32, there is a plus sign here. Unlike sign, you subtract and you keep the sign in front of the larger number. So that would be minus 7. And minus 25 minus 32, like signs, you add them and you keep the like sign. And that is all you need to know about addition and subtraction of numbers. Now, multiplication of whole numbers. If you had to multiply 326 by 4, you would set it down like this. You would begin multiplying by the 4. 4 6 24. You cross off that 4 and write it down here. That's what you were told to do. By now, though, you know why you do that, because that 24 is more than 10. You divide by 10, you get 2 up there, and you get 4 remainder here. It is this 4 that you put down here. And that 2 is 2 groups of 10. So 4 times 2 would give you 8. That's 8 groups of 10 plus that 2 will now give you 10 groups of 10. You divide by 10, you get 1 and you get 0 remainder. This 0 comes in the tens column. And then 4 times 3 would give you 12. But this one is one group of 10 of tens, which is really one group of 100. So 4 3s 12, 100 plus that one would give you 1300. Again, you divide by 10. You get 3. That 3 goes here. And this one here is really one group of 10 of 10 of 10, which is really 1,000. So you write that 3 there and you write that. So you have 1,304. So you know how to do this. Multiplication is actually a shortcut for addition. So this is 326 multiplied by 4. That really means add 326 4 times. 1 time, 2 times, 3 times, 4 times. And if you add that, you will get these same numbers you were getting here. 6 and 6 and 6 and 6 would give you 24. You cross out the 4 and put it here. And the 2 you carry over there. Add 2, 4, 6, 8, 10. You cross out, that's this 10. Cross out that 0, put it here, and take that 1 and carry it over here. 3 and 3, 6 and 3, 9 and 3, 12 and 1, 13. That's this 13. Cross out that 3 and put it here, and you're left with that 1 here, which you then, that's 1 is in the 1,000 column, you put it down here. Or you could look at it like this way. You add 326 to 326 first, and you get this answer, and then you add another 326, that's a third time, and you get this answer, and you add another 326 a fourth time, and you get this answer. Remember, we have to multiply by 4. So multiplication is a shortcut to addition. Now here is another multiplication, a little longer and more complicated. 326 multiplied by 34. You set it down like this, as if though you were going to add them, but you're not adding them. Then you begin multiplying by this 4. You multiply the 326 by the 4. So you get 24, you cross out that 4 and put it down here. You know why you do that. That 2 goes over here. 4 2s 8 and 2 10. You cross out the 0 and put it there. 4 3s 12 and 1 13. And then you cross out that 3 and put it there, and the 1 goes over there. We did that before. Now, this 3 that you are multiplying by is not really 3. It's in the tens position, so it's really 30. So 3 times 6 will give you 18. Now, when you cross out that 8, you do not put it in the ones column, because we are multiplying by 8, 10, 30. So you take that 8 and put it here in the tens column, and then you add a 0 here to make sure you don't get confused. So the 0 goes in the ones column. So 326, and that one is 7. Cross out the 7 and put it in the hundreds column. 3 threes, 9. There's nothing to add. So that 9 goes in the thousand columns. And now you add those normally. 4, 8, 10, which would give us 0 here. 9 and 1, 10 and 1, 11, which would give us 1 here, plus that 1 over there. So you get 11,084 if you multiply 326 by 34 without a calculator. So it is 326 multiplied by 4, that's this part here, plus 326 multiplied by 30, that's this part here. And so we add those two and we get this answer. Another way to look at that is multiply 34 by 6 and we get this. Then multiply 34 by 20, because this 2 is in the tens position, and we get that. Then multiply 34 by 300, because that 3 is in the hundreds position, and you get this. And you add all of those, and you will get back the same 11,084. Or you could add 326 34 times, and you will get back the same 11,084. Or you could add them one at a time, which is what your computer does. It adds 326 to 326, that's 2, gets that answer, and then it adds another 326 and it gets this answer, add another 326 and it gets this, add it 34 times. So your computer doesn't actually do a multiplication like that. Your computer do an addition like this, but it does it very fast. So when you say 326 multiplied by 34, it adds it very, very quickly 34 times. And finally, let's look at division of whole numbers. 84 divided by 6. So you would write it down like this, for the 84 here and the 6 here. You would say 6 into 8. You would say 6 ones, 6. You write that 6 down there, and you put a 2 down here. Now that is what you would do. Then you will bring down the 4, and now you have 24. You say 6 into 24. You say 6 fours, 24. Write the 24 there, subtract it, and you get 0. So your answer is 84 divided by 6 is 14. Now, that's what you do. Keep doing that. Now, the reason, though, that you do that is this. If you take 84 and you divide by 6, you're actually subtracting 60 from it, because this 8 is in the tens position. So when you subtract 60 from 84, you get 1. You get 1. You can subtract another 60. So this one is what goes here. So now you have 24 remaining. Now we will say 6 into 24. We are now in the ones position. So how many times can we subtract 6 from this 24? We can subtract it 1 time, 2 times, 3 times, 4 times, and then we arrive at 0. So this 4 is actually that 4. Now, this is what you are doing, but you don't know you are doing it. Now, you don't need to know and explain this for CXC. You do need to know how to do this, though. Division is a shortcut to subtraction. So let's say you have 84. Now, this is the other way around it. You subtract 6 from it once, and then 6 from it twice, and so on. And we can go right down to keep subtracting 6. Eventually, we get 0 down here. Notice how many times we were able to subtract 6? 14 times. So when you divide 84 by 6, you get 14. There are different reasoning behind that. However, please do the one that you are accustomed to doing, which is this 6 into 8, 6, 1, 6, remainder 2, bring down that 4, 6 into 24, 6 fours, 24, you get 0. Keep doing that. Now you have an idea why you are doing it, but you don't need to explain to CXC why you did it. So if you divide 84 by 6 and you get 14, what does that mean? Is it 6 groups of 14 or is it 14 groups of 6? Well, that depends. If you share $84 equally among 6 children, how much does each child get? Then you have 6 groups of $14 that each child gets. Or if you have $84 and you want each child to get $6, how many children will get $6? Now, in this case, you now have 14 groups of $6. So 14 children will get $6. So it depends. So let's try a little harder one. Divide 879 by 6. What you would normally is write 879 like that, set it up like this, long division, put the 6 in the front there, and you would say 6 into 8, 6 ones, 6, you write that 6 down here, and you subtract the 6 from the 8, and you get 2. You then bring down that 7 next to this 2, you get 27, and you say 6 into 27, 6 fours, 24, write the 24 down here, and subtract the 24 from the 27, and you get 3. Then you bring down that 9 here, and you get 39. So 6 into 39, 6 sixes, 36, and you subtract the 36 from the 9, and you get 3. At this point, you run out of numbers, whole numbers. So we are now at the 1/10th position. So we set up a point there, and there are as many zeros there as you would like on the right of that point. So we carry the point up here as well. Bring down that 0, and we now have what looks like 30. And we say 6 into 30, 6, 5, 30. You subtract this and you get 0. So essentially, you divide 879 by 6 and you get a 146.5. This is what you learned, and it's good. Keep doing that. By contrast, when I was in primary school a very long time ago, we had to do division of the sort 4 digit divided by 2 digits, and multiplication of the sort 5 digits multiplied by 3 digits, and calculators did not even exist in those days. Fortunately, we are past those days. Now, let's see exactly what you did here on the left, even if you were not aware that that was what you were doing. Now, keep in mind that you don't have to explain to CSEC what is on the next slide. This is just for your information. So let's start all over again. Now, this looks like a 6, but that 6 changes value depending on which of these numbers we are dividing. So when you say 6 into 8 and you get 1, you put the 6 down there and you subtract and you get 2. Remember, we are in the hundreds columns here. So that 2 there is not really 2, it's 200. And that 6 there is not 6, it's 600. So what you actually do is that you took that 8, which is really 800, and you subtract from it 600 once, and you get 200. Now, can you subtract another 600 from this 200? And of course, the answer is no. So this one that you were able to subtract once, the 600 from the 800, it is this one that you see here. And then when you bring down that 7, remember that is 70. So what you are doing is that you are adding that 200 that remain there, to 70, and now you have 270. Well, we are now in the tens position. So when we go now 6 into 27, what we are really saying is how many times can I subtract 60 from 270? Because remember, this number you see here is not 27, it's 270. So we can subtract it once, we get this. We can subtract it a second time, we get that. We subtract it a third time, we get 90 remaining. We can subtract 60 one more time, and so we get 30 remaining. Can we subtract any more 60 from 30? No. So what happens, this 4 that you see here, when you say 6 into 27, 6 4 is 24, that 4 is actually this 4. So you get 24, you subtract that, and you get 3. That 3 being in the tens position is not really 3. It's actually 30. Well, we then bring down that 9, and we now have 39. Remember, we are now in the ones position. So we add that 9 to this 30 over here, and we get 39. This 39 is that same 39 there. So 6 into 39, that's what we say. Actually, what we're saying is how many 6s can we subtract from 39? And so we can subtract a 6 once, and we get 33. We can then subtract a 6 a second time, and we get 27. We can subtract another 6 from 27 a third time, and we get 21. This is still bigger than 6, so we can subtract another 6 from 21. We get 4. The remainder is 15. We can still subtract another 6 from 15, which is 5 times now, and we get 9. Can we subtract another 6 from 9? Yes. And we get 3. Now, once we reach 3, we can't subtract another 6. So how many 6s did we subtract? 6. So when you say 6 into 39, and you put a 6 up here, 6 is 36, and you write that 36 here, and you subtract, this 3 is this 3 over here, but that's 3 in the units position. So what do we do now? Well, we go down to the 1/10th position. So normally we put a point and some zeros, 1 for the time being, but there are as many zeros as you need to the right of that point. And then we carry up this point here, make sure the point is there. Well, if this is 3 and we are going in tenths, how many 3/10ths do we have in 3? One of them has 10, another one has 10, another one has 10. So how many 6/10 do we have in 30/10? This is the 30. These are these little boxes that you see here, 30/10ths. So if we subtract from 30/10, we subtract 1/6/10, that is to say, we are left with 24/10, so that one of these 6/10ths have been subtracted. Then we try it a second time, another 6/10, that is this one. And then we now have 18/10ths. Can we subtract another 6/10 from that? Yes. We subtract another 6/10 from that, and we now have 12/10ths. Can we subtract another 6/10 from that? Yes. Up here, a fourth time. So we have a 6/10 here, 6 of those, and we still have 6/10 remaining. So we can subtract another 6/10 from that, 5 times now. So that is this last 6/10 here. That means that we have 0 6/10 remaining. So that when we say 6 into 30, we say 5, considering we have a point here, that 6 now becomes 6/10. How many 6/10 can we get into 30 tenths? And we say 5, and we bring down that 30 there, we subtract and we get 0. So this explanation on the right here, all of this subtraction, 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 and 60 changing value from hundreds to tens to ones to tenths, 1/10, you don't need to bother about all of these explanation here. This is just for your information. Now, all you need to know for CXC is what is in this blue box here. Now, general rules for multiplication and division of whole numbers. Remember, if you don't see a sign in front of a number, assume that the positive sign is there. Also, you would not normally write a positive sign in front of a number, positive number by itself. So there are only two rules. If the two numbers that you are multiplying or dividing, if they have the same sign, 2 plus sign or 2 negative sign, then you multiply or divide according to the question, and the sign for the answer is always positive. Second rule is if the two numbers have opposite signs in front of them, like one of them has a plus and one has a minus, then you multiply or divide according to the question, but the sign for the answer is always negative. So here are the two rules. Rule 1, if the signs are the same, there is a positive here and there is a positive there, though they are not written, you multiply and the answer is a positive. Here is a negative here and there is a negative there, you multiply or divide accordingly. To negative, you still get a positive in your answer. And then if you divide, and one is or multiply, and one is positive and one is negative, you work accordingly. 24 divided by 8, you get 3. But because you have unlike signs, the answer is negative, so 3. And the same thing holds true for this. Negative 25 divided by positive 10, two unlike signs, you are going to get 2.5, but because they are unlike signs, plus and minus, your answer will be negative. And that is all you need to know about multiplication and division of whole numbers. So what did we learn, especially as it relates to base 10? Base 10 uses groups of 10. Base 10 uses 10 digits, 0 to 9. 10 is not a digit in base 10. Base 10 uses place values like all other bases. But in this case, if you have 4,587, the 7 is in the ones position. So 7 ones. The 8 is in the tens position. That's 80. The 5 is in the hundreds position, 500. That is the tens of tens. And the 4 is in the tens of tens of tens, which is 1,000 position. So that's 4,587. Another way of expressing these positions is the use of index notation. 10 to the third power, then 10 squared, then 10 to the first power, 10 to the 0 power, beginning with the thousands at this point. Other base systems follow a similar pattern. Base 5 has 5 digits, 0 to 4, and the place values are, beginning from the far right, 5 to the 0, 5 to the first, 5 to the second, and 5 to the third. Base 7 follows a similar pattern, 7 digits, 0 to 6, again, 7 to the 0 power, 7 to the first power, 7 to the second power, 7 to the third power, and so on. Base 12 has 12 digits, 0 to 9, that will take care of 10. A will be the next digit, which will actually be 10, and B will be the 12th digit, which will actually be 11. But remember, you can't write 10 and 11, so you write A and B instead of 10 and 11. And again, the same thing applies. First position is 12 to the 0, second position 12 to the first, and so on. So we began by saying that in this video, we will learn how to evaluate numerical expressions by the use of the 4 basic operators on real numbers. So we did addition, multiplication, subtraction, and division of whole numbers. That is, we did this part. Subsequently, we will deal with decimals and fractions. And that's it for this video. That brings us to the end of video 1 of section 3 in section 1.